Hey guys, today we're going to be learning about scientific notation and more specifically how to convert that to standard form. So let's start with just getting some examples up here of what scientific notation looks like and what standard form looks like. So scientific notation is when you have a number multiplied by a multiple of 10. So for example, we have 1 times 10 to the 3, and that looks a little scarier than the normal numbers we look with. But that is just another way of writing 1,000. So other ways that you can look, they have decimals and numbers after decimals. So perhaps we have 1.2 times 10 to the 4th, and in standard form, that looks like 12,000. We can also have like 8 times 10 squared. That's just 800. This is a really good way of representing very large numbers. For example, if you have a number like 6.7 times 10 to the 7th, that's a little easier to write and understand how big it is than seeing this and having to count all the zeros to understand just how big that number is. So let's go into how exactly we get from this side to that side. All right, so when we look at numbers in scientific notation, we're really just moving the decimal place. So let's look at 9.1 times 10 to the 4th. So let's move the decimal place over to the amount of times 10 is raised to. So that's 4 times. So 1, 2, 3, 4. So that's where our new decimal place is, and we just fill this space with these zeros. So we get our answer to be 91,000 is equal to 9.1 times 10 to the 4th. All right, so another example, let's look at 8.6 times 10 to the 3rd. So let's take 8.6 and let's move the decimal over how many times? 3 times. So 1, 2, 3. And now our decimal is going to be here. And we'll fill in these places with zeros. So we get that 8,600 is equal to 8.6 times 10 to the 3. All right, let's do another example. Let's say 7.7 times 10 squared. We have 7.7, and we just have to move the decimal 2 places now. And we're moving it 2 places because that is the exponent that 10 is raised to. So let's move that 1 and then 2 times. So our decimal is now going to be here, no longer there, and fill in the empty space with the 0. So 770 is equal to 7.7 times 10 squared. Okay, let's look at 5.3 times 10 to the 7th. All right, so writing out 5.3, how many times should we move the decimal here? So to figure that out, let's look at the exponent on the 10, that's 7. So that'll be 1, 2, 3, 4, 5, 6, 7 places that will move the decimal over there. We'll fill in those places with zeros. And we get that 53 million is equal to 5.3 times 10 to the 7th. All right, and now for our last example, we have 12.4 times 10 squared. So what's the difference with this number? In all the previous examples, we only had one digit on the left of the decimal, and now we have two. But does that change our process at all? It doesn't. So let's just do it as we did before. We have 12.4, and we want to move the decimal. It does not matter that the decimal has two digits preceding it. All that matters is that we move it 2 places to the right, and we're moving it 2 places as that is the exponent on the 10 in scientific notation. So 1, 2. We fill in the empty spot with a 0, and we get that 12.4 times 10 to the second is equal to 1,240 in standard form. So I hope that helped. Good luck.